हेलो माय डियर स्टूडेंट्स, आइए आज इस वीडियो में हम स्टडी करेंगे डैम्प्ड ऑसिलेशंस. व्हाट इज डैम्पिंग? दैट इज व्हेनेवर द oscillations are decreasing in magnitude due to some dissipative forces, the oscillations die out, and that process is known as the damped oscillations, and the process is known as the damping. This is due to some dissipative forces, and dissipative forces are non-conservative forces, and for that the force of friction is a conservative force which is velocity dependent. Fx is equal to minus b vx. This b is the force constant of proportionality, and it describes the strength of the damping force. Now the total force acting on the body is Fx is equal to minus kx minus bvx. This term is from the, you can say, the simple harmonic motion, oscillatory motion जो है F is equal to minus kx, and this term is from the dissipative force, non-conservative force, frictional force. आप इसको rearrange करेंगे and you will apply a F is equal to max, and ax, acceleration, is the double derivative of displacement. This is this is the velocity, dx upon dt, and this is displacement. This is second order differential equation. Now this can be solved as have been taught to you in your mathematics classes. The solution is x is equal to a exponential minus b by 2m into t cos omega dash t plus phi. This solution is for small damping, and this part is known as the amplitude, and this is the angular frequency of the damping oscillations. That is omega dash is equal to k by m minus b square by 4m square for little damping. And you must remember that this frequency, damping frequency of the oscillations, is not equal to omega. That is, omega is the frequency in the absence of the damping. So let us discuss the case when b is large. Then what will happen? When b is large, you can say that omega dash will be equal to 0, and in that term this दोनों टर्म ये इक्वल हो जाएंगी. यहां से हमारा टारगेट क्या है? दिस टू डिस्कस दिस डैम्पिंग कांस्टेंट b इज इक्वल टू 2mk है. देखिए ये कंडीशन जो हमारे पास है, जब ये b 2mk के बराबर हो जाएगा, दैट इज नोन एज द क्रिटिकल डैम्पिंग. सिस्टम रिटर्न्स टू इट्स ओरिजिनल इक्विलिब्रियम स्टेट immediately without oscillation just after it has been displaced from the equilibrium position. Then what happens if the damping constant is greater than under root mk? Then that is the case of over damping. No oscillation, slow damping. कोई oscillation नहीं होगा, damping slow होगी. The system will come to its equilibrium position with slow damping with no oscillations. When b is less than 2 root mk, this is under damping. That is, system oscillates with steadily decreasing amplitude. So these are the three cases. These are very important from the examination point of view. Physics में जो होता है discussion is very important. Mathematical derivation आप ये कर सकते हैं. This is the graph showing the value of the effect of the damping force. That is when b is equal to 0.1 under root km. Damping is small. आप यहाँ दे सकते हैं, blue line से दिखाया गया है. This damping is small. येलो में क्या दिखाया गया? बी की वैल्यू 0.3 डैम्पिंग कांस्टेंट की. डैम्पिंग बड़ी तेजी से हो रही है, एम्पलीट्यूड इज डिक्रीजिंग वेरी रैपिडली, और मैं इनको ऊपर से टच करता हुए लाइन ड्रा करूं तो दैट विल गिव द इक्वेशन ऑफ दिस, यू कैन से एक्सपोनेंशियल फॉर्म. और ये हमारे पास एम्पलीट्यूड के लिए है, ये वीक के लिए है, और ये हमारे पास स्ट्रॉन्ग डैम्पिंग के लिए. इसकी यूटिलिटीज देख लीजिएगा. इट फाइंड्स एक्सटेंसिव यूज इन द लिक्विड्स व्हिच आर विस्कस. And in case of the, you can say, shock absorber in the vehicles, shock absorber में इसका रोल जो है हमारे पास क्या है? That should be critical damping. That is, B must be equal to 2 root mk. That is, whenever there is a bump, the spring should immediately come to its original equilibrium position. In case of over damping, क्या होगा over damping में? If the car is getting the second bump just after the first, the spring will continue to be compressed and it will not regain its original position. Okay, so in this case we have the application of this shock absorbers, and in case the damping is not there, then the suspension will continue to oscillate before coming to rest forever. So damping is very important. ये बड़ा इंपॉर्टेंट टॉपिक है, और इसमें आप ये इक्वेशन ध्यान रखेंगे, डिस्कशन जरूर करेंगे. ये एम्पलीट्यूड बताता है, बी की ये डैम्पिंग कांस्टेंट है, बी इसकी वैल्यू डिपेंड करती है एम और के ऊपर, मास एंड स्प्रिंग कांस्टेंट. थैंक यू फॉर वॉचिंग द वीडियो.